So, good morning guys. Welcome to my presentation about fluid kinematics. So, to start, let me give the definition of fluid kinematics first. So, kapag sinabi kasi nating fluid kinematics, it is branch of fluid mechanics that deals with the study of fluid in motion without considering forces and energies in them. So, basically, ang pinaka-idea ng fluid kinematics ay yung pag-aral ng motion or movement ng liquid. But in order to study that motion or movement of liquid, they disregard the different factors katulad ng temperature, pressure, and gravitational force. So, fluid kinematics is also called as geometry of motion. So, the reason kung bakit daw siyang tinawag na geometry of motion, kasi in studying fluid kinematics, they don't just rely on specific conclusion of scientific base, but that conclusion is backed up with a specific formula or computation to prove something or to prove the idea. So, for example, yung kay Archimedes principle, ito yung idea niya, an object will float if it is less dense than the fluid. So, yan yung tinatawag natin na conclusion niya. So, it has a general formula na F is equals to PGV, wherein F is the buoyant, P is the density, G is the gravity, and V is the volume. So, yung letter is stands up as the formula or computation to prove his idea. So the common topics involves or composed of fluid kinematics are flow of fluid in terms of steady and unsteady flow, uniform and non-uniform flow, compressible and incompressible, and the properties of the fluid. So these are the common topics that we will discuss today. Parameters in fluid kinematics. So before we start, let's define what is parameter means. So, in English term, a parameter is a numerical or order measurable factor forming one of a set that defines a system or sets the condition of its operation. So, basically, ang ibig sabihin daw ng parameter is the condition. So, every operation kasi or every system, there is what we call parameters. So, that parameters affect the whole system. So, for example, in fluid kinematics, specifically the flow, it has different parameters. These are the discharge, velocity, and cross-sectional area. So, that parameters affect the whole flow of the fluid. So, the first parameter in flow in fluid kinematics is what we call discharge. So, when we say discharge, it is a volume of water passing through a system in a given time. So, ang ibig sabihin daw nan, ito daw yung amount ng water na dumadaan every seconds or every minutes. Discharge has two common formulas applied in different area. So, the first formula is Q equals to V all over by T, and the second formula is Q equals to VA. Always remember that discharge has SI unit or International System of Unit of cubic meter all over by seconds. So without following this unit, maybe our computation is wrong or miscomputed. Like what I've said, discharge has two common formulas. So the first formula is Q equals to V all over by T. So Q refers to discharge, V refers to volume, and T refers to time. Always remember that this formula will be applied if the question is composed of volume and composed of time. So, for example, in problem solving number 1 here, how much discharge can the open faucets emits given the volume is 0.95 liters and time is 3 seconds? To get the discharge of the problem solving number 1, kailangan muna daw natin i-convert yung quantities into proper values and units. So for example, dito sa 0.95 liters, kailangan muna natin siya i-convert into cubic meter. So how we will do that? So we can multiply the 0.95 liters into 0.001 cubic meter in order to get the 0.00095 cubic meter. Or pwede din natin siyang i-divide ng 1,000. So, 0.95 divided by 1,000 is equivalent to 0.00095 cubic meter. After we convert the liters into cubic meters, let's check the time naman if seconds siya or not. If minutes siya, kailangan natin i-convert into seconds siya. So, since sa given problem solving, seconds naman siya, wala na tayong kailangan i-convert dyan. After that, ang gagawin na lang natin is i-transmute ito sa formula. So, ang given formula is Q is equals to volume divided by time, wherein the volume is 0.0095 cubic meter and the time is 3 seconds. I-divide natin ito, and after natin ma-divide, makukuha natin na ang answer na 0.0032 cubic meter per second. Ito yung discharge ng computation ng number 1. So the second formula of discharge is Q equals to VA, wherein Q is discharge, V is the flow of velocity, and A is a cross-sectional area. We will use this formula if given naman ang velocity at saka cross-sectional area. In problem solving number 2, given ang tinatawag nating velocity which is 2 meter per second and diameter is 0.4 meter. What is the discharge of the 5? So as we observe in the question, hindi given ang area, so definitely hahanapin natin muna yung area ng pipe. Since pipe is a 3-dimensional structure na circle, so definitely ang formula na gagamitin natin is the formula of the circle, which is the area equals to pi d squared divided by 4. In searching for the area of the pipe, we will use the formula of the circle, which is the area is equals to pi d squared divided by 4. So as we notice in problem solving, given naman na yung tinatawag nating diameter which is 0.4 meter, ang gagawin na lang natin dito is substitute natin siya sa d squared. To substitute, dapat ang total format ng formula is area is equals to pi d squared divided by 4 is equals to pi 0.4 meter to the second power divided by 4 is equals to pi close open parenthesis na 0.16 meter to the second power divided by 4. So to ask kung saan nanggaling ang 0.16 meter to the second power, minultiply lang natin yung 0.4 times 0.4 kaya naging 0.16 meter to the second power. And after that, i-multiply naman natin yung value or unit ng pi sa 0.16 meter to the second power. And pag nakuha na natin yun, i-divide naman natin sa 4 para makuha ang 0.1256 meter to the second power, which is the cross-sectional area. After we get the cross-sectional area or the area of the pipe, the second step that we will do is apply the formula of the discharge. So we know that the formula of discharge is Q equals to VA, wherein V is 2 meter per second and the cross-sectional area or the A is equivalent to 0.123 meter to the second power. And after that, i-multiply lang natin silang dalawa. Pag na-multiply na natin sila, dapat ang kinalabasan na answer dito is Q equals to 0.2152 meter to the third power or cubic meter per second. That is the application formula for question number 2. The second parameter that we should consider in studying the flow is what we call velocity. So when we say velocity, it is refers the speed of water passes in one direction. So basically, ang pinaka-idea nito, ito daw yung gaano kabilis yung water mag-travel from one point to another point. So ibig sabihin, any changes in position can determine the velocity of the water or the flow. So velocity has the general formula of mu equals to x divided by t. And always remember that the SI or International Unit System of the velocity is meter divided by seconds. Application formula of the velocity. So like what I've said, velocity has a general formula of mu equals to x all over by t. So mu is refers to velocity, x is refers to the distance, and t is refers to the time. So we have here the problem solving. So what is the velocity of water given that the distance is 0.45 meters and time is 30 seconds? So, given na dito ang tinatawag nating distance, which is 0.45 meters and time na 30 seconds. So, what we will do here is i-substitute lang natin sila. So, mu is equals to x divided by t. Mu is equals to 0.45 meter, which is the distance, and 30 seconds, which is the time. So, divide lang natin sila. 0.45 divided by 30 is equivalent to 0.015 meter to the second power. So, ibig sabihin, 0.015 meter to the second power is the speed or the velocity of the water that passes from one point to another point. So, the last parameter in studying the flow is what we call cross-sectional area. So, when we say cross-sectional area, this is the area taken up by the flow's cross-section. So, basically, ang pinaka-idea nito, ito daw yung spaces na fini-fill up or tinitaking up ng fluid habang dumadaan siya sa isang pathway, pipe, or container. So, cross-sectional area has a general formula na A equals to B multiply Y. And the SI unit or International Unit System of cross-sectional area is meter to the second power or meter squared. Application of the formula of cross-sectional area. So like what I've said, cross-sectional area has a formula of A is equals to B multiply Y, wherein A is refers to area, B is refers to cross-section, Y is refers to the depth or gaano kalalim. So we have here the problem solving. What is the cross-sectional area or cross-section area given that the depth of the passing water is 17 mm and area of the container is 0.15 mm? So always remember that we need to convert quantity or the values into proper quantities, which is the meter. So what we will do here is we need to convert 17 mm into meter. So how we will do that? To get the conversion, just simply divide the 17 mm divided by 1000. That is 0.017 meter, or we can multiply the 17 mm into 0.001. That is equivalent also to 0.017 meter. After we get the two values required in computing the cross-sectional area, just simply use the cross-sectional area formula, wherein A is equals to B multiply Y. A is equals to B, which is the 0.017 meter, times Y, which is 0.15 meter. Just multiply it to get the 0.00252 meter to the second power, which is the value of cross-sectional area of question number 1.
Flow. It is generally the motion of a fluid that is subjected to a different unbalanced forces or factors. Okay, ang flow po kasi ay sinasabing o it refers on how waters behave in motion. At ang flow po ay may iba't ibang factors. Ito po ay discharge, velocity, and cross-sectional area. So, meaning, kapag ang mga ito ay may nagbago, like sa discharge, velocity, or cross-sectional area, magbabago rin po yung status ng flow. And quantity of fluid passing through any section in a unit of time. So, ang flow po ay may general formula na rate of flow is equals to quantity of fluid divided by time. So, dun po sa general formula ng flow na rate of flow equals quantity of fluid divided by time, yung quantity of fluid po, dun we can determine it through volume, mass, and weight of fluid. Ang flow po ay may dalawang major types. Ito po ay ang steady flow and unsteady flow. When we say steady flow, from the word itself na steady, which means hindi nagbabago. While yung unsteady flow, from the word itself also na unsteady, which means may pagbabago. So, start po tayo sa first major types ng flow na steady flow. When we say steady flow po kasi, the fluid is in motion but streamlines are fixed. So, as you can see in the figure below, yung status po ng pag-flow nito sa fluid pipe ay hindi nagbabago. Kaya nga po siya naging steady flow. Kasi nga po, yung discharge or yung Q or yung velocity or yung U at ang cross-sectional area nito or yung A ay nagiging remains constant lang po. So, once na may naapektuhan, kahit isang factor lamang dyan, maaapektuhan din po yung whole status ng flow nito sa fluid pipe.
There are two subtypes of steady flow. The first type is the uniform steady flow. The main flow parameters of uniform steady flow do not change with distance along the flow in a manner of time. All of the flow parameters are constant with distance along the flank of the flow. The parameters kept constant due to unchanging condition in the path of fluid. As you can see in the representation of the pipe, from point A to point B, there is no change of parameters and only remain constant. If all of the parameters of discharge, velocity, and area are equal from point A to point B, then the flow is a uniform steady flow. The other subtype of steady uniform flow is the non-uniform steady flow. The main flow parameters or condition of non-uniform steady flow change from point 1 to another point but do not change with time. Unlike the steady uniform flow, the non-uniform flow has a change in the parameters where any of the flow parameters are varying with distance along the length of the flow. Some factors that cause of non-uniform steady flow are amount of discharge, level of discharge, and cross-sectional area. As you can see in the representation of the pipe, there is no change of parameters from point A to point B. The flow of parameters is not the same along the length of the flow. We can clearly see that the area and the velocity is not equal from point A to point B. Some of the main flow parameters are not constant, so therefore it is called a non-uniform steady flow.
Unsteady flow. Unsteady flow in which the quantity of a liquid flowing per second is not constant. So I just want to emphasize here that the flowing per second is not constant, and this is under unsteady flow. When we say unsteady, there is what we call continuous movement or change in a specific time, particularly in fluid mechanics. It is not constant because of the load or source of water na pwedeng makaapekto sa pagiging unsteady niya. For example, tidal effects. Effects of tides on streams requires consideration of unsteady flowing and not being constant every time. Another example is the passage of a flood wave. Water surface slope commonly increases during the arrival of flood wave. So kung matataas yung wave, possible na magiging unsteady yung flow ng fluids. It is either magiging mabilis or mabagal yung flows ng fluid dahil sa force na dulot ng tides or waves. Another one is it is transient phenomenon because it can become steady or zero flow. It is transient meaning hindi siya permanent or consistent sa kanyang flowing activity or flowing processes. So the velocity of a fluid particle changes with the time and position. Transient flows occur during discharge processes, during startup and shutdown processes of turbo machines, or in the case of fluid oscillations and water hammer processes. When we say water hammer processes, it is caused by the inertia effects of the flowing fluid being subjected to an abrupt changes in velocity. Under unsteady flow, it has two kinds, namely uniform unsteady flow and non-uniform uniform unsteady flow. Let us continue the discussion of the two kinds of unsteady flow by J-Rom.
So we have two types of unsteady flow, the uniform unsteady flow and the non-uniform unsteady flow. First is the uniform unsteady flow. So uniform unsteady flow, the condition at every point are the same but will change as time passes. Changes in discharge could affect the flow rate. So we have an example here, turned off water pipe. As you can see in point A, we have 2 mm flow rate while on point B, we have 3 mm. So as you can see, the conditions are the same while in power on water pipe. In point A, we have now 7 millimeter, and in point B, we have 6 millimeter. So the sudden changes in fluid discharge happens as we power on the water pipe. So next we have the non-uniform unsteady flow. The conditions change from one point to another along with the time. Any changes in charge or flow rate could affect the flow. So in our illustration, we can see the relationship between the parameters. As you notice, the discharge 1 is not equal to discharge 2, and discharge 2 is not equal to discharge 3. So as you can see, the viscosity in every point is different from each other. That is the cause of the different discharge at every point. So next is the parameter area. Area 1 which is not equal to area 2, but area 2 is equal to area 3. So we can say in the area that the wider the area, the more fluid to flow. So the next parameter is velocity. So in velocity 1 is not equal to velocity 2, but velocity 2 is equal to velocity 3. So in velocity, nagkakaroon ng pagkakaiba if ang fluid ay dumaloy sa isang straight path or sa paliko. If sa paliko dumaloy ang isang fluid, so we can assume that the velocity decreases.
I will discuss to you the two types of fluid, the compressible and incompressible fluid. So let's define first what is fluid. Fluid is a group of molecules that are randomly arranged and held together by weak cohesive forces and exerted in the wall of container. Fluid. Fluid is anything that can flow, capable of flowing freely like water, capable of moving. So the two major classification of fluid, liquid and gases. Why does gas is considered as a fluid? Because the particles of gas are free to move in any direction. Same with liquid because liquid is a substance that is able to flow freely, a liquid substance. Fluid like gas and liquid has the capability to flow. Solid does not, therefore solid is not a fluid. Yun na nga, ang mga particles ng solid, hindi siya nagmo-move. Kaya, hindi siya considered na fluid. Fluid has two types, the compressible and incompressible fluid. Compressible, a matter that can be compressed with the application of an external pressure. Gas can be compressed. So, in general, gases are called compressible fluid. These collisions give more time for the gas molecules to interact with each other, and more attraction forces may occur. These attraction forces reduce the motion of the gas molecules. This results in the compression of the gas. The particles of gases has a big spaces due to weak molecular bond it has. The example of gas are oxygen in air, water vapor in clouds, and etc. Isang example na nagpapakita ng compressibility ay yung scuba tank. Yung mga dala-dala ng divers kapag mag-i-scuba diving. They bring their own breathing gas at ang laman ng scuba tank na yon ay compressed air. So, bakit compressed air ang laman ng scuba tank na yon? For this reason, gases can be compressed so that a relatively charged amount of gas can be forced into a small container. So, yung mga compressed air na yon, nandun na yun sa scuba tank. Kaya, gas can be compressed. Incompressible, matter that cannot be compressed with the application of an external pressure or forces. Liquid is an example of incompressible object. The particles of liquid are close in each other that it can occupy any container. Bakit incompressible ang liquid? Because it does not generally expand to fill container but forms its own surface. Example ng incompressible ay water, soft drinks, soy sauce, and many more. Particle arrangement in phases of matter. Solids. Particles are packed tightly together in a fixed arrangement. Particles can vibrate but not move. So makikita natin sa figure ng solids na yung mga particles niya ay compact, hindi gumagalaw, they cannot move and collide with each other, unlike sa particles ng liquids and gases. So, kaya hindi consider na fluid ang solid because if we're going back to the definition of fluid, fluid has the capability to flow. Liquids. Particles are close together with no distinct arrangement. Particles can move and slide around each other. Makikita naman natin sa figure ng liquids na may mga spaces, so yung mga particles ay nakakagalaw. In liquid, particles are still in contact, but we have to remind na ang liquid has no definite shape. Madidictate lamang natin ang shape nito by its container. And last, gases. Particles are free-floating with no distinct arrangement. Particles move and collide with each other. Kikita natin sa figure ng gases na may mga spaces siya. So, yung particles ng gas, they can move freely, they can flow freely in any directions.